Alright, so we have a few more examples for finding the domain. So just to kind of review from the last video, so if there's something in the denominator, you're going to make sure you set it not equal to 0. If there's something under the square root, if it's in the numerator, you're going to make it greater than or equal to 0. Something we haven't looked at yet, if it's in the denominator, remember if it's in the denominator, it can't be equal to 0, so you would just make it greater than 0. So looking at the first problem, we have x minus 4. So for x minus 4, since it's under the square root, we're going to make it x minus 4 has to be greater than or equal to 0. Because remember, you can't have a negative number under the square root. So x has to be greater than or equal to 4. So x is greater than, so we're doing a big number, so we're going to be using 4 and infinity. 4 is going to get the bracket because it has the equal to. Infinity always gets the parentheses. Okay, for the second one, 3x squared minus 4. So this does not have a square root. This does not have a fraction. So, because it doesn't have those, you could plug in any number that you wanted to here. Okay, this is just a quadratic. You can plug in any number. All values of x will work. Positive values, negative values, 0 will work. So that means any number will work. So you want to put all real numbers, which is indicated by negative infinity to infinity, in our interval notation. Okay, taking a look at number 3. So this x is under the square root. So we're going to make it be x is greater than or equal to 0. X minus 5 is in the denominator. So you have to say x minus 5 cannot be equal to 0. So x cannot be equal to 5. So we have two things going on here. X has to be greater than 0 and x can't be 5. So the smallest of the numbers is 0. So first interval is going to be from 0 to 5. 0 is going to get a bracket because of the equal to. It can't be 5, so remember we notate that by parentheses, union, parentheses 5. That shows it can't be 5. And then because it says greater than, it can be any number bigger, so we're going to use infinity. Okay. Last example for domain, we have square root in the numerator. So like we've been doing, we're going to do x plus 2 has to be greater than or equal to 0. So x has to be greater than or equal to negative 2. Now we haven't seen this yet, but we have a square root in the denominator. So square roots, normally you make them greater than or equal to 0, but you can't have 0 in the denominator, so we're just going to make it greater than 0. So negative x is greater than negative 3. In order to get rid of that negative, we can flip the sign, so x is less than 3. So two things going on here. X has to be greater than or equal to negative 2, and x has to be less than 3. So it's really going to be between negative 2 and 3. Negative 2 is going to get a bracket because it has the equal to sign. 3 is going to get a parentheses because it doesn't. So that's our interval. Okay? So next we're going to take a look at range. And for range, for most problems you will have a graph to look at. But range, we're talking about the y values. So depending, the range depends on the domain. So domain, if you could plug in anything or whatever numbers you could plug in, the y values depend on that. So we are going to write interval notation. So for the first one, just to kind of review the asymptotes that we talked about earlier, if we were going to find the horizontal asymptotes here, because there's a 0 degree here and a degree of 1 here, it's small over big. Well, remember, if it's small over big, we have a horizontal asymptote at y equals 0. And then there's no holes because there's nothing to factor and nothing to cancel. But vertical asymptote, you would take the denominator and set it equal to 0. So we have a vertical asymptote at 2. Okay, so I'm just going to sketch the graph here. So we have a horizontal asymptote at y equals 0. And then we have a vertical asymptote at x equals 2. And then if you were to graph this, the graph looks like this. So when you're talking about range, we're talking about y value. So think about you're going up and down the y-axis. So starting, the small numbers are down here. So it looks like it's good from here. All these numbers are here. But then we have a break in the graphs, but then the numbers can keep going up, okay? So negative infinity to positive infinity, yes, but it can't be this number in the middle. Well, that number just happens to be that horizontal asymptote, which is 0. So the only number that it can't be is it can't be 0. It can be anything else. So the way you're going to write this is we're going to have from negative infinity to 0, and then union 0, because remember we put like that if we can't be that, and then it can go to infinity. Okay. For the next two, we're just going to use the graphs. So on number 2, when you have a y equals the square root of, this is a perfect square, minus x squared, this is going to make a semicircle. And to make the semicircle, the square root of this 16, which is 4, tells you how far over you're going to go. And it tells you how high you're going to go. So this makes half of a circle. It's called a semicircle. And the graph's going to look like this. So based off this graph, we're trying to figure out what the range is. So the range deals with the y values. So we're going to look at the y-axis. So it starts, this is the smallest y value gets to is 0, and the highest gets to is 4. So it goes from 0 to 4. 0 and 4 are included, so we're going to use brackets. And then the last one, we've already mentioned this e to the x before, but the graph of e to the x looks like this, and it does have a horizontal asymptote at 0. So if we're taking a look at the range, we're looking at the y value. So see how the y values start at 0 and they keep going up. Okay, so it starts at 0 and keeps going up. But because we have a horizontal asymptote, it really never touches that 0. So 0 is going to get a parentheses because of that asymptote. So it's going to go from 0 to infinity. Okay, and then our last problem. So we want to find the domain and range. And it says maybe use your calculator. I'm going to just graph it for you so you really don't need a calculator. So this is going to be a semicircle. Later in this unit we're going to talk about transformations. There is this negative here, which means it's reflected. So what this is going to look like, the square root of 25 is 5. So it is going to go over to negative 5 and over to 5. The only difference between the other semicircles, since it's reflected, is it's going to go down to negative 5 instead of being on the top. So this right here is the picture we need to look at. So for using this picture for our domain, remember domain talks about x values. Looking at the x values, it goes from negative 5 to 5, and it can be any value in between those two. Okay, negative 5 and 5 are included, so we're going to have from negative 5 to 5, and they're going to have brackets. For the range part, we are looking at the y values. So looking at the y values, we have y values that are at 0 and y values that are at negative 5. So be careful on this. So we have negative 5 and 0. Make sure you write the smallest number first. Some people like to turn this around. So negative 5 to 0 are the y values, and they are included, so they're going to get brackets. So that is domain. Just remember you're looking at x values, range you're looking at y values.